Now, next page, 79. So we have this thing called, what's the name of this? Differentiation, first derivative, or in other words, slope of tangent. As you noticed, it's quite a long process to calculate. Yes? Agreed? It's quite difficult to calculate this. Yes. So we're going to look at a collection of rules that will let us calculate it very quickly. Okay? So the first rule we're going to look at is how do we calculate the derivative if the function looks like this. Okay. So, using our formula, delta y over delta x is x plus hn minus xn all over h. That's the formula. So let's simplify it. You expand this one, and you get xn plus nc1 xn minus 1h plus nc2 xn minus 2h squared, etc., etc., etc. And then at the very end, dot, 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 you have minus xn. Remember doing this? Right. So, you notice again that the first one cancels with the last one. This usually seems to be the case. And all those h's cancel down. So h over h, cancel. And then h squared over h, cancel down to h, etc. However, at the very end, what do we make h equal to? 0. So all of these pieces go, and I'm left with this. dy dx equals nc1 xn minus 1. But remember, nc1 is the first part of the triangle, isn't it? So when you think about your Pascal triangle, what are the numbers running down the side? 1. And then when you move in, what number do you get? You get the row number. So like if you look at the third line, you get 1, 3, dot, dot, dot. And if you look at the fourth line, you get 1, 4, dot, dot, dot. So if I look at the nth line, what's nc1 going to be? N. So you get, this is our first formula. If y equals xn, then dy dx equals n x n minus 1. It's important. I'm sure a great many of you have seen this formula before. Yes? No? Well, not everybody does this at high school. Who's seen this formula before? Yes?
But never used it for an exam.
No? Okay. And now, those who've seen it before, I'm sure you all appreciate more where this formula comes from. No, thank you. Okay, that's our first formula. So, a very simple, quick example. Remember our x cubed one, if y equals x cubed. If I use this formula here, the power comes down, like here, and then what do I do to the power? I take away 1, so I get 3x squared. Now, remember the example I gave you when I said x equals 1? Remember that one? What answer did I get in that one? 3. So if I make x equal 1, what do I get here? Well, isn't that a lot easier? Yes. Okay, yes?
Instead of dy dx, do you write white line?
Yep, in the book there's many different symbols which I'll talk about now. So, once you have this formula taken down, I'll just say there's many symbols that mean dy dx, which means tangent line slope. You can have dy dx, of course. You can also write delta y delta x, but when h goes to 0. And some people like to write y dot y dash, or y prime, f dash, f dot, capital like this. Yes, I think I got them all. So these are all the different ways to mean slope of tangent, to mean derivative. Although the most common would be this one here, and also this one here. Okay. So, we have our first rule. Bring down the power, reduce the power by 1. By a similar process of using first principles, you can generate the other rules. Nobody wants to see the proof, so I'll tell you what they are. If y equals sine x, then the derivative is cos x. If y equals cos x, the derivative is minus sine x. If y equals log x, the derivative is 1 over x. And if y equals e to the nx, the derivative is ne to the nx. And finally, if y equals tan x, the derivative is 1 over cos squared x. Make sure you write all of those down now, please. What's that, Hassan? Yeah? Everything's okay? Good, good. Glad to hear that.
Y equals tan x.
1 over cos squared x. Now, can I do some examples now? Yes? Okay. So, Ahmed? Okay. So, y equals x squared plus x plus 1. And you want to calculate the derivative. So, which rule do I need for my list of rules? First rule. So, the power comes down, and then I take 1 from the power. So, what's the power now?
1.
Yeah, just x then. What's the power here? 1. So, I take it down, and I get 1. And then what's the power now? 0. What's x power 0? 1. And then finally I have 1 here. It's 0, yeah. Because it's like, 1 is like what number? X power 0. And when the 0 comes down, it's 0. And this is like x1, and this is like x squared. In other words, there's a quick way to do this as well. If you have like 4x, the derivative is 4. You just take the coefficient. And also, if you have something with no x in it, like here, if there's no x, then there's no derivative. So another quick example, y equals x cubed plus 2x squared plus 1. Okay, what's the derivative here? 3x squared plus 4x. Done, that's it. Now let's move on to one a little bit trickier. There's one example, there's another example. Right, what about y equals square root x? Well, what do we have to do first? Turn it into a power. What power is square root? A half. So therefore, the derivative would be bring down the power, and then reduce the power or take 1 from the power, a half minus 1, and that's the answer. Okay, so there's 3 examples to write down. So I've basically done question 1 and 2 there for you. Did you write these down? So I can do another example? And before somebody asks me, yes, those rules are in the formula book. So, what else do you need to know except how to read? Okay, I'll move down a little bit.
Rules?
All of this table
It's there?
is in the book, yeah.
Good.
Can I do another one now?
The example.
Okay, so I've done really 1 and 2 there, but what about something like number 3? If I say 9x plus y minus 3 equals 0, and I want to calculate this, I can't really do it because I don't know what y is, but that's easy to fix. So what should I do first? Just rewrite it, so I get y equals minus 9x plus 3. Now I can calculate it. What will it be? Minus 9. Okay? And then I'll do one like D.
Is this example from 3?
Yeah, that's 3a. Now this is 3d. Find dx dy if 8x plus 8y plus 5 equals 0. What do I do first, do you think?
You rewrite it.
Rewrite it so that
8y. No, just take y out.
now, this is where we have to be careful. Please, everybody look up and listen for a moment. This is different. Look here. This is dx dy, which means you treat x as if it's like the function and y if it's like the variable. So instead of dy dx, I have dx dy, which means instead of having y equals dot 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 x, I should have x equals dot 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 y. So a little bit of rewriting here.
Oh, because you have the y as well.
X equals minus y minus 5 over 8. So now what is dx dy? Remember what would it be? Minus 1. So the y acts like the variable and the x now acts like the function, the answer. So the only reason I included that is to try and expand your mind. X and y does not always have to mean x is the variable and y is the function. It could even be the other way around. There's no reason it has to be that way.
Oh, it's.
They're just swapped.
I just.
Yeah, mind expanded. Right, everybody look at 1a, tell me what the answer is. Don't write it down, just look at it and tell me what the answer is. 56 x power 7. How long did it take you to do that? Seconds. So it is not a big ask if I say do all of question 1. No reaction, because it's not a big task if I say do all of question 1. because you just did 1A in about 3 to 4 seconds. Right? So you could probably get all of question 1 done in 2 minutes. Right? In number 2, I want you to do the first 4. And in number 3, I want you to do the last 4.
Is it first 4?
Yeah,
Number 2.
yeah. And number 3 is the last 4.
How about 4?
4 is for those people who are bored and want to do it.
But I think most questions in the exam will come like number 4.
No. Now, hang on. Just before you start these, please listen carefully. Look at number 2b. What is the log function there? It is log 7x to the power of 9. You see that?
Yep.
You have a formula for the derivative of log. What is the derivative of log? 1 over x. Do you have log x here?
Yeah.
No, not log x. What do you have? Log 7x power 9. Not log x. So you need to simplify that. Using what rules can you simplify that? Funny enough, the rules of logs. The first rule of log would change that into what? It'd be, no, first rule of log.
Yeah.
It'd be what?
7.
Log 7
Log 7.
plus log x power 9. Yes? And then the fourth rule of logs would let you take the 9 down from the power, leaving you with log 7 plus 9 log x. Anyways, my point is, in 2b, you need to use rule of logs to simplify first. I'll say that again. Everybody look up. In 2b, use rules of logs to simplify first, before you use your derivative rules. Got it? Alright, start those now. All of number 1, the first 4 in number 2, and the last 4 in number 3. Now, you've noticed